construct a context-free grammar for the language L is equal to WC W power R such that W belongs to A comma B the whole star. So W is set of strings formed with A and B. W power R is reverse of W. So in between W and W power R you have a letter C. Now since, see what can be the possible strings in W? It is A comma B the whole star. So since it is star, it should accept string of 0 length. So included epsilon, A, B, A, B, BA, BB can be the possible strings in W. Now what can be the possible strings in L? If it is going to take epsilon, W and W power R is going to be epsilon means it should accept C, and then if W is going to be A, then ACA, BCB, AACAA, ABCBA, etc. These are the possible strings in the language. Now we'll try to construct the context-free grammar for this language given above. So the possible set of productions be S goes to C. We'll start with the primitive symbol. We can derive C from S, but before that we need A and A at the last. If it is B, then B at the last. Now let me take like this. ASA, S goes to BSB. So with this possible set of production, definitely it will be possible to derive all the strings in the language. So whatever may be in between, one A is coming, then that should be coming in the reverse also, W power R also. So what can be the set of non-terminals here? Yes, set of terminals A, B, C, and then start symbol, yes. Let me try and derive a string in this language, ABA. I'm going to take my W as AB. No, to make it as a different, okay, let it be ABB. So W power R is going to be BBA. So my X is going to be ABBCBBA. We'll try and start with, see, since it starts with A and ends with A, let me use the second rule, second production. So we'll go with S goes to AS. Since you have a production, S goes to AS. And for this A, the next symbol I want is B and B. So let me use for this S, third production, S goes to BSB. Now what else I want? I want B and B. So again I'll be using for this S, I can derive a BS from this S. So BSB, and I'm copying this BA. Now for this S, I have derived ABB, BAA. Now this S, I can use the first one, ABB, C, BBA. S goes to C. So starting from S, applying the grammar G one or more times, I am able to derive A, B, B, C, B, B, A. So this belongs to the given language. L is equal to WC W power R such that W belongs to A comma B the whole star. So this is the corresponding grammar for the given language. Now we look into one more problem. L is equal to A power n, B power n, C power m, D power m, such that n comma m greater than or equal to 1. So this is not a regular language. Now look at the pattern of this particular language. It is having equal number of A's and B's followed by equal number of C's and D's. So if it is going to be A power n, B power n, we have already seen here we have the answer. It's going to be AA and ASA. That's going to derive the same. So you have two such component. So let me take like this. X goes to AB, X goes to AXB. We'll derive the first A power n, B power n. Again, Y goes to CD and Y goes to CYD. We'll derive this C power m, D power n. Not a problem at all. But now we want to define a grammar, context-free grammar for A power n, B power n, C power n, D power n together. So we need to provide some connectivity. It should be able to derive the productions from X to derive AB strings and then the productions from Y to derive CD strings. Now this completes our task. Now what are the set of non-terminals here? You have S, X and Y. Set of terminals A, B, C and D. Start symbol is going to be S only because we are trying to give the context-free grammar for this language. L is equal to A power n, B power n, C power n, D power n. So this is going to be the productions, set of productions, and the entire thing is going to be the grammar for the above language. Now if you want to derive any language belonging to this particular any string belonging to this particular language, let me take AA, BB and CD. This n is equal to 2 and m is equal to 1. So I am taking a language, this string, this X belongs to this language L, so that it has to be derived with the help of this 5 productions. So I have to start with the start symbol, and start symbol is XY. Now for this X, let me take first one A, X, B and then Y. Again for this X, let me take A, B, B and Y. So now we have derived the first 4 symbols of this particular string. Next is we need to derive CD. So since you have a production X tends to A, X, B, you are using it here. Since you have a production X tends to A, B, you are using it here. Since X tends to XY is a production, you are using it here. Now for this Y, you need to derive only CD now. So directly you have a production Y tends to CD. So starting from S, applying the grammar G one or more times, we were able to derive A, B, B, C, D. So this belongs to the language L.